Now, random variable. The outcome are qualitative and the probability attached to the outcome are quantitative. So now, if we assign a specific quantity, that's a real number, to each outcome of that sample space, then this real number assigned to each outcome, or we can say a sample point of a sample space, is called random variable. Now, we take an example. Suppose we have a coin tossed twice. So the sample space we have head, 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 tail, tail, head, tail, tail. Now let us suppose x represent the number of head that come up. So the sample points, what we have sample points? Head, 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 tail, head, and tail, tail. So here we take a random variable x which represent the number of heads come up. So we assigned head head means two head. In that second sample point, only one head. Third sample point, we have only one head. In the last sample point, we have zero head. So we assigned 2, 1, 1, 0. Now, the probability of each sample point is what? We have 4 sample points and the probability of each sample point is 1 by 4, 1 by 4, 1 by 4, 1 by 4. Now, if we ask the probability when x is equal to 0, first we have to know the meaning of that. It means when the random variable is equal to 0, it means no head appears. So what's the probability? We have 1 by 4. And if we say one head appears, it means the random variable x is equal to 1. So one head is appear in two cases, this one or this. So we add 1 by 4, 1 by 4. And if we say x is equal to 2, it means exactly 2 head appears. So there is only one case and the probability along this is 1 by 4. So here we assigned 0, 1, 2 as a random variable. Now suppose we throw 3 coins and we get in sample space head, head, head. And the second point is head, head, tail, head, tail, head, tail, head, head, tail, tail, head, tail, head, tail, head, tail, tail, and tail, tail, tail. So here if we consider a variable x be the number of head that's come up, then we have to find the probability assigned to the random variable. So first we make the table. So we have an 8 sample points. These are the 8 sample point. We take a random variable x, that is number of head appears. So in first 3, second sample point we have 2 heads, 2, 2, 1, 1, 1, and the last no head appears. Now we have 8 sample points. So the probability of each sample point is what? 1 by 8, 1 by 8, 1 by 8, 1 by 8, and 1 by 8. Now here we assign the 3 random variables. That is the random variable x is what? 0. It may be 0, 1, 2, 3. Now if we say, because we have to find the probabilities the assigned random variables, so if random variable x is equal to 0, so probability is what? It means no head appears. So in the one case that is 1 by 8. Similarly, if we say probability x is equal to 1, it means only one head appears. So we have 3 cases, we add all 3's, we get 3 by 8. Similarly, if we say 2 head appears, that is probability the random variable x is equal to 2. So we have 3 cases, we add all 3's, so we get 3 by 8. And if we say all heads appear or 3 heads appear, that is the random variable x is equal to 3. So we have one case that is 1 by 8. So here you have to remember these are the probability of each sample point of a sample space, and this is what? This is a probability of the random variable which we assign the random variable. Means x is equal to 0, the probability x is equal to 0 is 1 by 8, x equal to 1 is 3 by 8, x equal to 2 is 3 by 8, and then when x is equal to 3 is 1 by 8. Now what is in probability distribution? If you understand the concept of random variable, now discuss the probability distribution. So here is the distinct value of discrete or continuous random variable. Whatever we can say, continuous or discrete, we have two type of random variables. So the distinct value of discrete or continuous random variable x together with their associated probabilities define the probability distribution of random variable x. So if we have an says x random variable x and the assumed values, that is x1, x2, x3 and so on, xk, which we assigned in the previous example 0, 1, 2, 3, and with associated probabilities is p1, p2, p3 and so on, pk, then the probability distribution of x is under this one, that is probability of x is equal to x1, we get p1. When we say the probability random variable x is equal to x2, so we have p2. And when we say probability when x is equal to x3, so we say the probability is p3. And similarly for the nth term, or we can say the kth term, the probability is pk. Now here when we write the set, this is what, this is a random variable, or we can say the assumed value of random variable, and this is what, this is the probability of that random variable, assumed value of random variable, that is xi. So when we write in the form of set, when we write xi, associated probabilities xi, so this is what, this structure is called probability distribution. So if you remember, when we write the binomial distribution, so we write b and np. Here n represent the number of trial and that p, small p, represent the probabilities. Here you have to note that if we add all these probabilities, so we get what? We get is equal to 1. So summation px is equal to xi, we get 1. So you remember that property, and also you have to remember these are what? These are the probability of random variable. It's not the probability of sample point. Now the probability distribution is categorized, which is based on the discrete or continuous variable. So we can say the probability distribution having the two parts, that is defined for the discrete variable and continuous variable. And if we have a discrete variable, so we have two functions, probability function, and in that case, in discrete case, we say probability mass function, and the similar function if the variable is continuous, so we say that is probability density function. And the second function, that is cumulative distribution function. So in case of this discrete variable, we say cumulative mass distribution function, and if the variable is continuous, so in that case we say cumulative density function. So you just remember, if the variable is discrete, so the word mass is used here, and if the variable is continuous, so in that case we use the density, the word density. So if discrete, so we use the mass functions, and if the continuous, we use the density function. Now, and another way you can also says the random variable has two part. The first one, there are two type of random variable, discrete and continuous. And if the variable is discrete, so we study the two functions, that is probability mass function and distribution function for discrete variable. And if the random variable is continuous, so we study the two function, that is probability density function. So the probability mass function, which is in discrete variable, it make, or we can say it represent or pronounce the probability density function if the variable is continuous, and the distribution function for continuous variable. So you also remember in the form of random variable. Now now we discuss, first we discuss the discrete random variable. So first you have to understand the random variable. We have two type of random variables, discrete and continuous. So first we study the discrete random variable. So if random variable take at most a countable infinite number of value, so it is called discrete random variable. Means random variable when we take 0, 1, 2, 3, 4 and so on. So these are what? These are discrete numbers. So we can say these are this if we say x is a random variable, so we can say this is a discrete random variable. Now there are two functions, the probability mass function. The first one, probability mass function, that's sometimes we say PMF. So corresponding to each xi is what? The value of a random variable that our discrete random variable of x can take, and we associate a probability of occurrence is pxi. So we have an xi, the random discrete random variable, and corresponding probability is pxi. So now if we can describe the probabilities associated with random variable x by the table of values, but it will be easier to write a journal formula that permit one to calculate pxi by substituting the appropriate value of xi, and thus such formula is called probability mass function. What is that? That is probability mass function. Now now and you have to remember, the probability mass function is denoted by fxi, and that's we write in the suffix capital X, or simply sometimes we say fxi. Thus the function that gives the probability to realize the random variable x equal to xi is called probability mass function fxi. Therefore we can write the probability function f x xi is, or sometimes we just write fxi, or we can also use the p x is equal to xi. In the first example I write p x is equal to 0, probability x is equal to 2. So these are what? This is a probability mass function. Here you have to remember, if px is equal to xi, so it's and is a probability mass function, then it should be satisfy the two properties, that is the all probability function is greater than equal to 0, and if we add all probabilities it should be 1. Means if we add all the probabilities p1 p2 p3, so we get the summation of that is 1. So the second function, which we discuss in the that chart, so that is discrete distribution function, or sometimes we say cumulative mass function, because we are taking the discrete and random variable, so we use the word mass function. Although a discrete random variable, we say capital X, is described completely by a probability mass function, so it is often convenient to deal with another related function known as probability distribution function. And the probability that the value of the random variable x is less than or equal to some number x is defined as cumulative distribution function, and it is denoted by capital X of x, that is f x of x, or we write px is less than xi, and which is summation fxi, or we write pxi. Means if we write x is less than equal to 2, so it may be, if suppose we have random variable 0 1 2 3, and we say probability x is less than 2, so we write x is equal to 2 plus probability x is equal to 1 plus probability x is equal to 0. Similarly, if we say less than 3, so we add one more, that is x is equal to 3 plus probability x is equal to 2 plus probability x is equal to 1 plus probability x is equal to 0. And similarly we can write for less than 1, so in that case probability x is equal to 1 plus probability x is equal to 0. So these are what? These are cumulative mass function, or we say just discrete distribution function. Now we take up one problem, that is, if we have a random variable x, the following probabilities of the function values are defined as when x is equal to 0 1 2 3 4 5 6 7, and corresponding probabilities is given 0 b 2b 3b 3b b square, 2b square, 7b square plus. Here we have to find the value of b and determine the distribution function of random variable x. This distribution function means is a discrete distribution, so we can also say cumulative mass function. And also we have to evaluate when probability x is less than 6, when probability x is greater than or equal to 6, or when the x lies between 0 to 1. Here you have to remember x is what? Random variable, and that random variable is what? Discrete, because the value is defined on 0, 1, 2, 3 and 4, so on. Now first we discuss the first part, that is we have to find the probability, the value of b. So by the property of the probability mass function, if we add all the probabilities, so here you have to remember this is what? This is the probability mass function, PMF. 2b, 3b, b square, 2b square, because these 0, 1, 2, 3 are not a sample point. These are what? These are the random variables. So if we add all of them, so it should be equal to 1 if it is probability mass function. So we add summation pxi is equal to 1 when I is 0 to 7. We have 7 random variables. So we add all these 7, 0b, 2b, 2b plus 3b plus b square plus 2b square plus 7b square plus b is equal to 1. Now if we simplify that equation, so we get the value of b, two values of b, that is -1 and b is equal to 1 by 2, 1 by 10. So we're neglecting the negative term because probability cannot be negative. So we take b is equal to, that is 1 by 10. So here if we take b is equal to 1 by 10, so that property is satisfied and we can say these are the probability mass function. Now the second thing, we just substitute the value at on the place of b, so we get the table on corresponding to 0, 1, 2, 3. That's not a small x, that is we can say capital X, and these are small x. Now px is equal to x, that is these are probability mass function. So we get 1 by 10, 2 by 10, 2 by 10, 3 by 10, 1 by 100, 3 by 100 and 17 by 100. We just put the value of b in that table on the place, that is 1 by 10. Now because we have to find the cumulative mass frequency distribution function, or we can say cumulative mass frequency. So there are two ways to write. First, from directly from the table, you just write 0 and then add 0 with 1 by 10, so we get 1 by 10. Now add the 1 by 10 with 2 by 10 and right here, that is 3 by 10. Now add this 3 by 10 plus 2 by 10, we get 5 by 10. Now 5 by 10 plus 3 by 10, we get 8 by 10. Then 8 by 10 plus 1 by 100, we get 81 by 100. Now 81 by 100 plus 3 by 100, we get 83 by 100. And 83 by 100 plus 17 by 100, we get 1. So these are cumulative mass frequency. And what is that representing? This means when x is less than, capital X is less than x. So here it means when probability x is less than 0. So what we get? 0. When probability x is less than equal to 1. So what it means less than 1. So we add 0, 0 plus 1 by 10. When probability x is equal to 0 and when plus probability x equal to 1. So we get 1 by 10. And if we say probability or the random variable when x is less than equal to 2. So we add x equal to 0, 1, 2. Here we get 0 plus 1 by 10 plus 2 by 10. So we get 3 by 10. Similarly for x is less than 3. So add all less than 3. And similarly x is less than 4, as x is less than 7. And when we write x is less than 7, so we all add all the PMF, that is probability mass functions, so we get 1. So in that way, and these are what? These are cumulative mass frequencies, or we can say distribution function for the discrete random variable. These are the distribution function. So this is what? This is the probability function. These are what we say, these are probability function, and that is what? this is cumulative, or we say distribution function. So in probability we study two functions. You have to remember probability function and distribution function. The third part of the problem is what? We have to evaluate probability x is less than 6, greater than equal to 6, and between 0 to 5. So this is the table. So I say this is what? This is the probability mass function. These are cumulative mass function. But in that case, we have to evaluate probability when x is less than 6. So probability when x is less than 6, so we can say when x equal to 0, x equal to 1, x equal to 2, x equal to 3, x equal to 4, and x equal to 5. So this is, we use x equal to 0, it means is equal to 0. That is a what? Probability mass function. We add 0, 1 by 10, 2 by 10, 2 by 10, 3 by 10, and 1 by 10. So we obtain 81 by 10. Or this can be defined by probability when x is less than equal to 5. So in that case, if we say probability x is less than equal to 5, so is a type of cumulative mass function which can be we directly write from the table. Now if we say we have to find the probability x is greater than 6, so we just add greater than 6 plus probability x is equal to 7, so we obtain 19 by 10. When we say probability lies between 0 to 5, so we add probability x equal to 1, x equal to 2, x equal to 3, and x equal to 4. So equal to 1, this one, we add all these 4, we get 8 by 10. So here you have to remember, this is what? This is the probabilities which is obtained by the help of what? Probability mass function. So don't confuse between the probability mass function and cumulative function. One more example to clarify. If x is a random variable for the probability mass function is px. So here whenever we use the word probability mass function, so you have to understand, or you have to remember that it means we are talking about the random variable is what? Discrete. So here we have an px, and here given px is defined as x by 15 when x is equal to 1, 2, 3, 4, 5, and elsewhere 0, means everywhere 0. So we have find the probability x is equal to 1 or 2, and the second part when the probability when x is lies between 1 by 2 and 5 by 2 divided by x is greater than 1. So here first part we have to find the probability x is equal to 1 or 2. So what's the mean of or? Means the probability when x is equal to 1 plus when probability x is equal to 2. So when probability x is equal to 1 means we have x by 15, that is 1 by 15, we replace x equal to 1. When we say x equal to 2, so we write 2 by 15, that is we get 1 by 5. Now the second part, we have to find the probability when x is lies between 1 by 2 and 5 by 2 divided by when x is greater than 1. So here the meaning of that is when x is lies between 1 by 2 and 5 by 2, given that x is greater than 1. So this is a conditional probability. So we use, if we suppose this is what? A, and this is B, that's a probability A given B, if you remember the formula. So we write probability A intersection B divided by probability of B. So here if this is completely A and this B, so we write probability A intersection B and divide by probability of B. So here what it mean? The x lies between 1 by 2 and 5 by 2. So what's the value of x? So it can be 1, 2, not 3, because 5 by 2 means 2.5, and intersection when x is greater than 1. So when x is greater than 1, so it take 2, 3, 4, 5, right? So the intersection of these two is what? 2. So we can say when x is equal to 1 and when x is equal to the intersection is 2, so we can say probability when x is equal to 2 and divide by the probability x is greater than 1, we can write 1 minus probability x is less than 1, less than equal to 1. So we just take 1, the probability when x is equal to 1, so we write 1 minus probability x is equal to 1, and probability x is equal to 1 is for 1 by 15, and x equal to 2, we get 2 by 15. On simplify, we get 1 by 7. So in that way we can evaluate these probabilities. Here you have to remember, this is the probability mass function, and here we use the concept of distribution given, that is conditional probability.
Discuss about discrete. Now today we are going to discuss both discrete and continuous. What is discrete random variable? What is continuous random variable? Let's start. If a random variable takes at most a countable, finite or countable number of value, then it is called discrete variable. Means if a, if a random variable having value finite or countable. If it is countable, then it is known as discrete random variable. For example, tossing a coin in 3 times and getting probability of head, or also tossing a coin 2 times, 3 times, 4 times, 5 times. This is the example of discrete data. Number of accidents in a city in daily basis. If you count a number of accidents in your city, it is limited. Okay, guys, you may be count. Third one, number of patient in a hospital. Number of patient of hospital may be per day 10, 20, 30, maximum 100, 200 or 5000. Means it is countable. For example, this is a basic example. If we have a function fx is equal to x plus 2 where x belongs to n means natural number. For x, here put x is equal to 1, we get 3, 2, we get 4, 3 we get 5, and so on. Next is fx is equal to x square. For x belongs to n means if you put value of x 1, we get 1, 2, we get 4, if 3 we get 9, and many more. This is the probability mass function. Actually, when we discuss, we talk about the discrete function, we must talk about the probability mass function. A function, say px is equal to x, is called probability mass function of a random variable x if these are conditions. First, probability of x greater than equal to 0 for all value of r. X belongs to r. R means real value. And second one, summation. This is summation. X belongs to r is equal to 1. Means sum of probability always equal to 1, and probability we have always greater than equal to 0. This is an example of discrete data. Okay, guys. Now come to continuous. A random variable which takes every possible value with its range of variation is called continuous random variable. Means, for example, height, weight, velocity is continuous. Marks of student in a class is also continuous. If we talk about the continuous random variable, we must talk about the probability density function. Okay, guys, probability density function of a continuous random variable which is called PDF, means probability density function. For example, a function fx is called PDF, probability density function of a random variable x. For function of fx is greater than equal to 0 and limit of minus infinity to plus infinity fx dx is equal to 1. Means range of probability minus infinity to infinity always equal to 1. In case of discrete, sum of probability always equal to 1. Okay, guys. Now this is one example for continuous function. You must remember one thing when we say discrete random variable, we must say about probability mass function, and if we are talking about the continuous random variable, we say we must say PDF, probability density function. Okay, guys. Now this is a small example. Fx is equal to 1 upon 9 x square, range 0 to x, x range 0 to 3, and 0 otherwise. This is a function. Now check this is our PDF or not. Now starting with minus second property, we must every if any function is PDF, then it must contain limit is equal to 1. Okay guys, let us check. Minus infinity to infinity fx dx is equal to range. We have break a range minus infinity to infinity. Minus infinity to 0 fx dx plus 0 to 3 fx dx plus 3 to infinity fx dx. ठीक है? Now this is 0, this is 0. We have only 0 to infinity x square by 9 dx. Here 1 upon 9 x cube divided by 3, limit 0 to 3, 27 by 27 1. Means this is a PDF of this function is a PDF. Means continuous random variable is also PDF. Second example, if we have fx is equal to 6x minus x square, limit 0 to 1 and 0 otherwise. Now check this function is PDF or not. If this function is value of this function within limit 0 to 1, we are getting 1 is PDF, otherwise this is not a PDF. Let us check. 0 to 1, 6x minus 6x square dx, 6 into x square, integration of x square by 2 minus 6 into integration of x square, x cube by 3, limit 0 to 1, we have 3x square minus 2x cube, 0 to 1, 3 minus 2 is equal to 1. Okay guys, we getting 1. This is the PDF of the given function. Okay guys, now tomorrow we are going to discuss some characteristic of property mass function and expectation of what is the expectation and how we can solve the numerical, some basic numerical based on expectation. Okay guys, thank you.